Okay, last time we were discussing about circular motion and we were finding or finding an expression for the centripetal force and centripetal acceleration. Now let's move on. Very common examples. A stone is tied with a rope and moved in a vertical circle like this. This is a vertical circle. This is a stone and it is connected to the center of the circular path. Okay, now let's give it a title. A stone and rope in vertical circle. So this is an object of mass m. This is rope, which is 1 radius long. This is the center of the circular path. Now, in order to make this mass move in a circular path, there should be a tension acting towards the center of the circular path. That is the simple thing. Everybody believes that. But note, tension in rope is not constant. You might wonder why. Why the tension is, if it is moving with a constant speed, the tension should be constant. Because weight of mass or object sometimes acts along the centripetal force and sometimes against. Now it is all about weight and the position of the mass. Let me reduce the size of this thing. Now let's say this is position A. This is position B, the lowest possible position. Now, highest possible position. Now, pay attention. When object is at A, the centripetal force is acting downwards. Gravity is acting downwards. Tension is downwards. So somehow tension and gravity get together to produce the required centripetal force, or T equals to mv square over r minus mg. at A. So T will have this value. Later you find out that it will be the least value of T. Now, what will happen at B? In this case, tension is upward, centripetal force is required in upward direction, and weight is acting downwards. So tension now has two responsibilities. Tension has to provide the force to overcome weight. So tension equals to mv square over r plus mg. So here are some important. Least possible position, maximum tension, hence if rope ever breaks, this is most likely the point. So if you gradually increase the speed of the rotation of the mass and you are waiting for rope to snap at any point and you want to predict where this rope will break, then your answer is B. B is the most likely position where the rope will break, because rope will always experience maximum tension at B. Rope will always experience maximum tension at B. So,
Sir Ekman, could you go to the note, please?
could I go to what?
The note on the right.
Okay, this one. Least possible position, maximum tension. Hence, if rope ever breaks, this is most
No,
likely
sir,
the point.
the one on top.
Okay, okay, this one.
Yeah.
Tension in the rope is not constant. Even if object is moving with constant speed, tension will not be constant, because weight is changing its direction continuously.
Yeah, okay, thank you.
Minimum tension at highest point, TA, centripetal force minus weight, maximum tension at lowest point, TB, and TB equals to mv square over r plus mg. Now, this is the physics for something moving in a vertical circle. What if something is moving in a horizontal circle? Mass plus rope in horizontal circle. In that case, because the horizontal circle will look like an ellipse when we will be looking at it from the side. This is the mass. Okay. To make something move in a horizontal circle, the rope has to be at an angle. This is mass M. This is the path of object, horizontal circle. This is rope, and the tension is this way. This tension will always have two components. One will be acting this way. This angle is theta. This will be T cos theta. And there will be a vertical component T sin theta. Remember, the weight of the object is acting this way, and in this case, centripetal force has nothing to do with the weight. No. For horizontal circle, for fixed speed, there will be fixed tension at constant radius. If the radius stays same, there will be a constant tension. Tension will not change in this case because the direction of weight will always stay the same with respect to the tension. Number 2, vertical component of tension is equal to weight. That T sin theta component will always be equal to mg. T sin theta will be always equal to mg because T sin theta is upward and mg is downward, and they cancel one another. Horizontal component of tension is equal to centripetal force. T cos theta equals to mv square over r. So now T sin theta equals to mg and T cos theta equals to mv square over r. So that's some very important and very basic things. Not, I won't think that they're very difficult, but they're very important. Examiner keeps asking them. Why tension in this case cannot be perfectly horizontal. So examiner asks this question very often, that if this is the case and there is a theta, why theta cannot be 0? Why the tension cannot be like this? And the answer is, no matter how fast we make it move, there must be a component of tension that has to overcome weight. It is only true for something that has no mass. You can make something with no mass move in a perfect horizontal circle with tension being perfectly horizontal. But if something has any mass whatsoever, there must be a component of tension that has to overcome weight. Okay, so answer will be there must be a vertical component to overcome weight. So angle can be very small, but cannot be 0. Hence, tension in this case is never horizontal. Okay, this is the case of vertical circle and horizontal circle, and they are very commonly they appear in exam. Now, let's move forward. Today we will start uniform. Okay, just one second. Angular displacement and velocity. If something is moving at a circular path and we are observing it from the center, we will find out that that object is not changing its distance from the center. If it is moving in a perfect circular path and we are observing it from here, this is the origin, you will find out the distance of the object always stays same from here. But we can still observe that the object is moving. If the distance is not changing, what else do we observe when we see that the object is moving? We see that this object was here. This is position P1, and sometimes after the object goes there. This is position 2. So object has gone from position 1 to position 2. So we have observed this change. We have observed change in angle. So this angle is called angular displacement. Displacement. Angle swept at center of the circular path in radians. Now, this is a new term, radians. What are radians?
Sir, what do you mean angle swapped?
Listen, do you see that this is the radius original position number one?
Yes.
Do you think the radius has moved from there to there?
Yes.
So if it is a wiper on a windscreen, do you think that this is the area that is being swept by the radius?
Oh, yeah, yeah.
So that is what this term is used for. Swept means area that radius moves or covers.
Okay.
And we go for the starting position of that area and final position of that area. So that gives us two radius joining at the center of the circle. The angle between those two radii is the angular displacement.
Yeah,
You can
okay.
consider it, you can also consider this radius as line of sight. So you sight an object at position P1, and then after some time you sight it at position 2. So what angle is being swept by the line of sight?
Theta.
Yes, this was line of sight number 1, this was line of sight number 2, and line of sight has swept an angle theta. Or what else you can say? Move an angle?
Yeah, I
That
guess.
will also be okay, but swept is used for the angle in this case. But if you say moved, it will be completely okay. Radians. One radius is an angle at center of the circular path when distance on circumference is exactly 1 radius. The angle will be 1 radian. Okay, and let me make another circle for this one. This is a circle. This is radius number 1. This is radius number 2. Now, this is radius. And if this arc length is also 1 radius, then this angle is 1 radian. Now, if the arc length becomes 2 radius, the angle will become 2 radians. If arc length becomes 3 radius, 3 radian, 4 radius, 4 radian, 5 radius. How many radius are there in a circumference? The formula for circumference is 2 pi r. So there are 2 pi r's in one circumference. So that means how many radians are there in one complete circle? If each
2 pi.
radius makes 1 radian, then 2 pi radius will make 2 pi radians.
Yes.
One complete circle is 2 pi radian. But we know in degrees, how many degrees are there in one complete circle?
360.
So this is very basic information that you need to know, that 2 pi radian is 360 degrees. Pi radian is 180 degrees. You can remember any one of them, it is okay, and you can figure out any degrees in radians or radians in degrees. And one more thing, that normally students think that pi is used as a unit over here. The pi is just a number. Pi means 3.142 or whatever the number is in the calculator. The pi is not a unit of radian angles. When we say 2 pi radian, it means we are saying 6.28 radians. Pi radian means 3.142 radians. So pi is just a number over here. Some students think that pi is a kind of unit for radian angles, but it is not. It is just a number. Now, radians, angular displacement. What will be angular velocity? Angular velocity. Rate of change of angular displacement is called angular velocity. Angular velocity equals to angular displacement divided by time. So symbolically, omega equals to change of theta divided by time. So there we go. This is a very important formula, and units are very important here. If this is measured in radians, this is measured in seconds. So omega is in radians per second. Okay. So omega will be measured in radians per second. Angular velocity is change of angle divided by time. Let's um, uh, keep going. Now we will be discussing uniform circular motion. Like, what if something is moving in a circular path over and over again? So this is an object which is moving this way with linear velocity v. The radius of the circular path is r. Mass of the object is m. If object moves in a circular path repeatedly, it will have frequency and time period. So these two things, time period and frequency, they are related to anything that happens over and over again. Everything that keeps on happening again and again will have a time period and will also have a frequency. Now, frequency is revolutions per unit time measured in hertz. But sometimes for mechanical reasons, we also do revolution per minute, RPMs. So it is also a kind of a frequency, but we need to convert it into revolutions per second before we put it into any formula. Then time period is time taken to move around circular path once. Okay, now for one revolution, time taken equals to capital T distance moved equals to 2 pi r, one circumference. Angular displacement move angular displacement will be 2 pi radians. So angular displacement is 2 pi radians and distance move is 2 pi and time taken is t. We will use this to find different kinds of speeds now. Linear speed equals to distance travel is 2 pi r divided by capital T. So here is a formula for speed. 2 pi r divided by t. Now, angular displacement, angular velocity. Two pi divided by capital T. So omega equals to 2 pi over T. So here is another formula. Now we will be mixing some formulas here. I hope you can see 2 pi over T here as well, which is equals to omega. So by mixing these two formulas together, we can make another formula. V equals to omega R. So this is also a very useful formula. Now, here, as we know, 1 over T is equal to F. So omega equals to 2 pi F as well. So this is another form of the same formula. Okay. So too many formulas, I guess. Now we can find new formulas for centripetal force and centripetal acceleration. Centripetal force was mv square over r, but we now know v equals to omega r. So Fc equals to m omega square r square over r. So one r cancels with one r, and we have a new formula for centripetal force, m omega square r. And if we believe that F equals to ma, so Fc equals to ac, we can see that centripetal acceleration is omega square into r. For something moving in a circle path, kinetic energy equals to 1 over 2 mv square. But now it can be kinetic energy equals to 1 over 2 m omega square r square. For something which is moving in a circular path, we can also use this one. So let's end today's lesson over here. Tomorrow we'll be doing some past paper questions and completing some small leftovers. See you tomorrow.
Okay, sir. Assalamu alaikum. Have a nice day.
Walaikum assalam.